interact with for this one. We're gonna have to go get some kids. Yeah. There we go, you guys are kids. Come on, have a seat.
Kevin.
More kids, come on, there we go. All right, I guess we should start then. All right, I am Dr. Chris. I'm Dr. Chris. That's right, I'm Dr. Chris, and I'm going to be talking to you today about sound in geoscience. And I'm going to start off by saying to the kids out there, does anybody know what instrument I am playing? Oh, what? That's right, a banjo. That's right, it's a banjo. A banjo, there we go, from one of the young lasses in the audience, a banjo. And what sort of music do people play with banjo? Oh, there we go. Pardon? Well, country music, but deliverance. Yes, well, that's a particular piece of music. But camping music, well, might as well. Disco? Not quite disco. Pardon? Traveling music? Well, I guess it all goes under bluegrass. Bluegrass, and that's one of my favorite. Bluegrass. I got a little bluegrass band. Maybe you'll see us sometime, maybe not. So I'll go on to the next one and say, how many people out there play an instrument? And what instrument do you play? Piano. Clarinet. You play piano? How long have you been playing piano? A long time? Your mom made you play piano? That's okay, music is awesome. You play piano too, holy cow. And what do you play? The which? Recorder. You should also pick up the banjo, because the banjo's awesome. You play guitar, you gonna be a rock and roller? I tried to be a rock and roller. The trombones, you get a ska band? No? All right, well, this brings me to a question I like to ask after this one, is what makes all these instruments sound different? Why do instruments sound different? Does anybody know why? Oh, why do they sound different? Because they have different things to make them sound different. But what are those specific things that make them sound different? Say, why does a guitar sound different from a fiddle? Well, definitely size, the size of the instrument. Also what the instrument's made of, whether it's made of wood, plastic, acrylic. Also depends on what sort of strings they're being struck on. Or in the case of a saxophone, they're being blown, or a trumpet blown, or in the case of drums, they're being slapped on. Which brings us to the next one I'm going to ask you. Next thing I'm going to ask you. What is sound? What is sound? What is sound? Can anybody tell me what they think sound is? That's right. They're vibrations. They're vibrations through the air. Pardon? Are they big waves or little waves? So that's right. Sound are tiny waves. They sort of look like this, with peaks and troughs going around and around through the air. They're also tiny vibrations and tiny movements of molecules that travel, say, from the banjo into our ears, where we pick it up. They're like receivers. From there, our ears translate the sound, well, the eardrum does, and sends it to our brains, which act like computers. But mostly, we have computers more acting like our brains. We're able to make an image in our mind of what we're hearing. So in this case, a banjo. Since we can tell the difference between different instruments, maybe a violin, a fiddle, could be saxophone, or a chicken. Now, chicken's not an instrument, but you know what I mean. Which brings us to the next thing, seeing with sound. Now, there's some creatures on this planet that are able to use sound to see. Can anybody name me at least one of those animals? All right, I'm gonna ask someone who hasn't answered the question yet. That's right, a bat. A bat can see with sound. Whales? Yes, I think they do. I'm not a zoologist, but I did 2 animals. I did bats and dolphins. So what does a dolphin want to do with those fish? That's right, eat them up. Eat them. Arr. So it sends out so the dolphin sends out some sounds. Now those sound waves move out and they bounce off the fish and come back. And then the dolphin's able to make a picture in its mind of where those fish are. And of course, what's it going to do? It wants to eat them, doesn't it? There we go. Eats them up, jumps off into space and says, so long and thanks for all the fish. All right, who gets that? Raise your hand. What's it from? Hitchhiker's Guide to the Galaxy. There we go. Helen wins the prize. There we go. Hitchhiker's Guide to the Galaxy. Normally the older crowd gets it, but obviously our, I don't want to say younger crowd, not so older crowd gets it as well. And who said bats? You said bats? That's right. So there's bats flying around. I lived in Australia for a number of years, and in the middle of the night, you could hear them flying around. They're making high-pitched chirping sounds. Why do they do that? Because they're hungry, and what are flying around at night? Moths and other little insects. And what does the bat want to do with those bugs? Eat them up, that's right. So, just like with the dolphins, it sends out a signal, little chirping sound. The sound bounces off the bugs, comes back to the bats. Bats here with their ears, and starts eating those bugs. Bow, zam, pow. That's something that Batman would do. Now, what is this called when creatures use sound to find things? I've asked you a bunch of times. What's it called? Echolocation, that is correct. Echolocation, that is correct. Echolocation, we're gonna have to give you like a prize for answering most of the questions. That's right. Now, to bring it back to Earth science, there's actually something similar to echolocation, and it's called seismic. Seismic. So in seismic, what we need is to have some sort of big object or big explosion to send sound waves through the Earth. And I'll explain really quickly. What is that from? What? Is that from, did you say Minecraft? Minecraft! That's right. Minecraft, that's right. How many people here play Minecraft? Raise your hand. All the kids, of course. All right, so what we need is a big, heavy object or an explosion. In this case, we're going to smack the ground. Bang, 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 bang. Sending sound waves into the Earth. And just like with echolocation, sound waves come back up, but some of those sound waves bounce back up. Now, what we also need on the ground to be able to pick those reflections up is we're going to need ears. But we also need to have ears on the ground. Ears on the ground, don't we? Do you think we'd have a bunch of people with their ears to the ground trying to do this? Or would that be silly? That'd be way too silly, that's right. So, in real life, we have these giant machines called a virus-size unit, and it shakes the ground and puts sound into the Earth. Sound into the ground. Put sound into the Earth. Now, the Earth doesn't just look like mud. Has anybody been out to the mountains? And what do you see on the side of mountains? Is it just one giant chunk of rock, or what is it? Have you seen layers on the sides of the mountain? You see layering on the sides of mountains, don't you? It's not just one big chunk of rock. It's layering that have formed over millions of years. And that's the same directly under our feet. The Earth has layers. Now, just like echolocation, is that the sound bounces off those layers and comes back up. What we use is things like ears called geophones. Called geophones. Now, the sizes aren't quite this big, of course. And what we do is we take those signals that are picked up by the geophones, and it takes a little bit more time than this, but we make a picture. We can actually see layering within the Earth. We can see the flat layering under the Earth from the sound. Sometimes these pictures can get pretty complicated. In this case, the Earth has started to bend and squish together, creating anticlines. And sometimes there's so much pressure from the ground bending, they actually break against each other. That's when earthquakes happen, or that's when faulting happens. This is where I ask, how big do you think this image is? Like how much space do you think? Do you think this is the size of this room? How big do you think some of these images can be? A really big area? How really big? 10 to 20 kilometers long. That might be farther away than your house is right now. And 2 to 3 kilometers deep. So remember before I showed you that the Viber size unit? You may think it looked big compared to those images, but really, it was really, 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 really small compared to one of these images. Now I'm going to leave you with one last thing before we go, is that we can also make 2 or 3-dimensional images with the sound that we send through the earth. On the left, on the right, we've got a braided river system. And that's what you would see on the surface. You could go see the Bull River and it could be like this. On the left is a picture from seismic that's 2 kilometers under the ground, covered by dirt for millions of years, after millions of years. And they almost look the same, don't they? You've got braided on the surface of the earth and a braided, and it's showing us what it looked like millions of years ago, that there was a river that's now been covered over. And that's how in geoscience we can see with sound. Thank you.